Do you guys remember the equation for a circle?
For what?
No.
What are we solving the area?
Just not the area, just the equation for write the equation of a circle.
What? 2 pi r?
No.
You just draw a circle. There you go. That's it. It's actually pretty good. What? Is that freehand?
That was freehand.
Did you just see him make it, or like did you watch it?
Actually, not bad. You're right.
No. Oh, like that. It's like,
Hey, that is pretty darn good for me. Look at that. Yeah, huh? That's right. I am the man. Now, with the circles, obviously, if we started out normally, if we go through the origin, messes it up a little bit now.
My circle is so bad. She's right.
It's better than your kite list.
What's that?
That's radius.
Radius. Okay. So the radius is that. Now, when you write the equation of a circle, if we're centered at the origin, there's no h, there's no k. Very, very, very easy. It is x squared plus y squared. It is r squared, where r is your radius. You guys all knew that. You've done that. It is simple. Okay? You did that last year in section 10.7 in geometry. But what you guys did right off the bat was you didn't center it at the origin because that's boring. We just walked right through and jumped right into an h and a k. So you guys did stuff like this.
Are you sure?
Pretty sure. Where h and k are the center. And r is the radius. Yes, ma'am.
when I took the practice ACT, there was a lot of geometry on that,
Oh, there's a ton of geometry.
and I forgot a lot
The-
of geometry.
The ACT, when you start doing the ACT stuff, your geometry is a good 60–70% of it because it encompasses so much stuff. Because they look at what should you have done by your junior year, is the way they look at it.
I forgot, man.
When you're dealing with these things, it's
Let me tell you.
ridiculously simple to work with. When you're going to graph circles, basically all you have to be able to do is find the center and walk the radius. So when I ask you to graph a circle, you're going to do this. If I have, let's see, x plus 2 quantity squared plus y minus 4 quantity squared equals 16. Well, where's your center? Negative 2 and 4, and what's your radius? 4.
Did you just put this?
I did.
Okay.
The radius is going to be 4, because remember that equals 16 is equal to the r squared. Okay. So what you wind up having to do here, if you're going to plot this circle, this is going to be very difficult. There's my center. Radius is 4, so you have to go up 4. 1 down 4. Left 4. And, oh, I don't know, right 4. What do you think we should do then?
Draw some.
So you had to draw a circle.
Well, you lost it, right?
I'll get over it. And I'm done. Like I said, when you did this last year, circles are very, very easy to work with in terms of conic sections. What I'm going to have you guys do, and you might have done this with Seth, is we're going to work a little bit with the writing of the equations that are a little bit weirder. So this,
It's like an eye.
with this. Let's write the equation of the circle whose center is 9, 3, and the radius is 4. Excuse me. Oh no, what is my h? What is my k? Is it -9 or 9?
What? Oh, okay, when you put it in the equation,
Yes. Does it equal 4 or does it equal 16? Does it equal 2? Done. That's it. Go to the next problem. Like I said, circles are relatively simple in a roundabout kind of way. I'm rolling. Now we're on
object.
Now we need to rewrite it into the standard form. Remember last week when we did this, when we had to do the completing the square?
Yeah.
Okay, basically same thing. Excuse me. So in this case, we have x squared plus y squared minus 4x minus 2y minus 4 is 0. What we're going to do is we actually have to complete the square twice because we have an x squared and a y squared value. Okay? So group them together and move the constant over, just like we did before. Put away your phone. No, you can do that later.
I didn't take the notes this morning, so that was the issue.
Notice I started right off the bat by putting in the plus blanks. I put in 2 blanks on the left side. How many should I put on the right side? 2. Good. You're going to see that more and more as we go along because the conic sections that we deal with are going to have x squared and y squared terms. So you're going to have you'll have 2 values of completing the square. Okay. So you started out. Hopefully by now we've gotten somewhat decent at this. Half of -4 is, that drops in our parentheses. You square it and you're adding 4 to both sides. Yay. We do it again. Half of -2 is, drops to your parentheses. Put this with a plus between here. Square -1, you're adding 1 to both sides. And you're done. Where's your center and what's your radius?
2, 1, 3.
Good. That's the kind of questions I'm going to ask you guys to do is identify the center and the radius. I don't think we need to graph these because it's kind of a waste, to be honest with you. So if you can tell me that the center is at 2, 1 with a radius of 3, I'm good with that. Okay? Let's get to the weird part then. Let's write the equation of the line that is tangent to the circle at x squared plus y squared equals 13. And it goes to the ordered pair 2, 3. What is the equation of the line that is tangent to a circle? X squared plus y squared equals 13. That goes to the point 2, 3. What does it mean to be tangent to a circle? Do you remember? How many spots does it touch it? 1. Now, what happens when you're tangent to a circle? First of all, where's this located at, like center-wise? It's at the origin, okay? So it's at the origin, and just so you can see this a little bit cleaner, I'm just going to kind of, we don't really need graph paper, but sometimes it helps to show this first part. Oops. So if I'm at the center, is my origin. I'm going through the point 2, 3, which means my circle is going to go around that. Okay. My radius is going to be the square root of 13. Okay. It's going to be the square root of 13. I don't know what that is in terms of value. It's more than 3, less than 4. But to be tangent to something, you touch it at one spot. And when you touch something at one spot, you're going to be perpendicular to that radius. Okay. So when you're talking about the tangent line stuff, it's going to be perpendicular to the radius, which means you're going to find some slopes. Now, if I'm at the origin and my ordered pair that I want to get to, I want to be tangent to, I want to write the equation to, I need to find the slope of this line. Well, the slope of this line is going to be the opposite reciprocal of the slope of that line. Do you agree?
Yeah.
Well, when you're dealing with the origin and an ordered pair, remember your slope, the change in y, change in x. Bless you. Well, isn't that just 3 over 2? Since I'm centered at the origin, my second set of x values and y values will be both 0. So it'll be 3 minus 0, 2 minus 0 for change in y or change in x. So my regular slope is 3 over 2. What's perpendicular to 3 over 2? Negative 2 over 3, very good. So my perpendicular slope is negative 2 over 3. So there's the slope of the line that I want to figure out. But what's the point that it goes through? 2, 3. Do you remember how to write the equation of the line given a slope and a point? Point slope form, very good. Point slope form, see if you remember that. Point slope form is that y minus y sub 1 equals your slope times x, or excuse me, slope times x minus x sub 1. Point slope form is also an h and a k, in case you didn't know that. So basically what we're going to do here is just substitute in those slope and the point and resolve for y. And that gives you your equation of the line into regular slope intercept form. Whenever we write equations with lines like this, if I'm going to the tangent, I want you guys to get in the habit of going back to slope intercept form because you've got a y equals button. So might as well get y by itself. So fill in the blanks. There's a 3. There's 3. And we're going to get 2/3 x minus 2, right? Distribute and add over. So you get y minus 3, negative 2/3, x plus 4/3. Now when I add my 3 over, am I add it as 3 or what could I add it as in my head? 9 over 3, very good. So what's 9 plus 4? That's it. You're done. Okay. Remember, the only reason why I wrote it as 9 over, I brought the 3 over, I just added it over as 9/3 because I can do those fractions in my head then. That's probably the most work that you'll have to do with any of this. It's just write the equation of the tangent line. Okay? And it's not that difficult. I'm pretty sure most of you guys probably did that last year. Probably. I hope you did. I think you did.
Mr. Seth did that a lot.
So this shouldn't come as a surprise for them. So I have another one like that then. Do the same thing real quick here. Write the equation that's tangent to this circle through that point, please. And I think we might just call it a day.
Really?
Like I said, there's not much to circles, really. I forgot to leave it open.
This big room.